In this video, we're going to look at simplifying square roots, cube roots, fourth roots, and more. In the previous video, we looked at how to simplify a square root, like the square root of 32, and I said to look at your list of perfect squares, and we were looking for the largest perfect square that divided evenly into 32, and that would be 16. So we broke 32 down to 16 times 2. Then we took the square root of 16, and that was 4. We don't know the square root of 2, or it's not a nice whole number, and so we leave that under the radical, and we got 4 square roots of 2. I want to show you another way to do this because this method will help you when it comes to cube roots and larger radicals. Let's take 32 again, and let's break it down to its prime factorization. So I'm going to do a factor tree, breaking it all the way down until I get to prime numbers. And it just so happens to be 5 2's. 2 to the 5th power is 32. So that's the prime factorization for 32. Anything we have a pair of under here indicates that that's a perfect square in there. 2 times 2 is 4, and we know 4 is a perfect square. Here's another 2 times 2 is 4, and 4 is a perfect square. And so basically we have this, okay, which means that when I take the square root of something squared, the square root of 2 squared is going to be 2. So a 2 is going to come to the outside for this one. The square root of 2 squared is going to be 2 again, and then this 2 here will stay underneath the radical. So these two 2's on the outside get multiplied together, and you see we get 4 square roots of 2 just like we did here. Let's look at another one. The first method we use, square root of 75, we're looking for the largest perfect square that divides evenly into 75, and that would be 25, and it goes 3 times. The square root of 25 is 5, so that comes on the outside. The 3 stays underneath. Okay, if we do it using this second method, we would break 75 down to its prime factorization, which would be 3 times 5 times 5, or 3 times 5 squared. We're looking for pairs. Pairs make a perfect square. And so the square root of 5 squared is 5. That would come to the outside, and the 3 would be left underneath. All right, so like I said, that could help us when we get to cube roots and trying to simplify a cube root. When we're doing this, we're going to be looking for perfect cubes under the radical. And so instead of looking for pairs, we'll be looking for groups of 3, because that would indicate a perfect cube. So let's break 24 down to prime factors. And you see that we end up with 2 times 2 times 2 times 3. All right, because we have a group of 3 2's, that indicates that we've got a perfect cube under there. 2 times 2 times 2 is 8, and 8 is a perfect cube. All right, so we can think of it like this. A cube root and a cubed cancel out. The cube root of 2 cubed is 2, so that comes to the outside, and we will have a 3 left under the cube root. Make sure you keep bringing this little 3 that indicates a cube root over into the next step of the problem. A lot of people leave that off, and if you leave that off, then it's incorrect. Excuse me. All right, the cube root of y to the 7th. If we want to think about it, you know, this y to the 7th is y times itself 7 times. And again, we're looking for groups of 3 because we're doing the cube root. And so we've got 2 groups of 3 with 1 left over. The cube root of y cubed is y. The cube root of this y cubed is another y. And then this one's going to be left under the radical. The two that came out here we can multiply together and get y squared. And then you have y squared cube root of y. Now you don't have to write this out every time. I'm trying to show you what's happening here. But in general, you can see we're looking for how many groups of 3 we can get out of this. We got 2 groups of 3 with 1 left over. All right, let's try another one. The cube root of 40x to the 5th. Now if I break it all the way down, let's get 40 broken down. And then x to the 5th. So let's see, I have 2 times 2 times 2 times 5 times x times x times x times x times x. Again, I don't care if you write all of this out. I'm just going to do it the first few times so you can see what's happening. I have a group of 3 2's and a group of 3 x's. If you want to rewrite those with cubes on them, you can. You don't have to. Just whatever helps you see this. Now I'm going to go ahead and put these x's back together. These are the two things we can take the cube root of. These are what's going to be left underneath. The cube root of 2 cubed is 2. The cube root of x cubed is x. And then left underneath the cube root, we're going to have 5x squared. All right, let's try one without writing it all the way out. Oops. Let's try that again, Miss Carter. All right, cube root of x to the 14th. I don't really want to write out 14 x's, so I'm going to think about this in how many groups of 3 can I get out of x to the 14th, okay? So 3 goes into 14 4 times, so I should be able to get 4 groups of 3. That means outside I'm going to have x to the 4th. 4 groups of 3 is 12, so there would be 2 left over. So there would be 2 left under the radical. All right. What if I have the cube root of w to the 5th, x to the 4th? Again, what comes out is how many groups of 3 we could get, because groups of 3 make a perfect cube. All right, out of w to the 5th, we would get 1 group of 3. Out of x to the 4th, we would get 1 group of 3. And then we would have leftovers. We would have 2 w's left underneath and 1 x left underneath. Okay, this is the same for 4th roots, except we're looking for groups of 4, because groups of 4 would be something we could take the 4th root of. So let's start with 32. Now we already did the prime factorization of 32 just a minute ago. It was 2 to the 5th power, so 5 2's. So you can see we have a group of 4 2's there. And so essentially this is 2 to the 4th and 1 2 left over. The 4th root of 2 to the 4th is 2, and then we have 1 2 left under the radical. Okay, if we have the 4th root of b to the 9th, again we're looking for groups of 4. Rather than writing out 9 b's, I'm just going to think about groups of 4. How many groups of 4 could I get out of b to the 9th? 4 goes into 9 2 times, so I could get 2 groups of 4, and then I would have 1 b left under the radical. All right, now, let's see. Let's do some that are a little bit more complicated. (54x cubed y to the 5th z to the 7th). Okay, I'm back to a cube root, so I'm looking for groups of 3. I'm going to break 54 down. 9 times 6, 9 breaks down to 3 times 3. 6 is 3 times 2. All right, I'm gonna say I see a group of 3 right here. I'm gonna try to do some of this in my head, not have to write it all out. Let's see. Well, I'll at least put this. I'm gonna have 3 cubed times 2. X cubed, I'm gonna be able to take the cube root of that. Y to the 5th, I can get 1 group of 3 out of that and have 2 left over. Z to the 7th, I can get 2 groups of 3 out of that and have 1 left over. So I'm going to underline all these so I don't miss any of these. These are all the things I can take the cube root of. The cube root of 3 cubed is 3. The cube root of x cubed is x. The cube root of y cubed is y. The cube root of z cubed is z. And then I have another z, so that's going to be z squared. Now let's see what's left under the radical. We're going to have a 2, a y squared, and a z. All right, let's do another one like that with a 4th root. 4th root of 48, a to the 10th, b to the 11th, c to the 7th. All right, we're looking for groups of 4 because it's a 4th root. Let's break 48 down to its prime factorization. You can see we have 4 2's and a 3. All right, so we've got 4 2's and a 3. Groups of 4 out of a to the 10th. I can get 1 group, 2nd group, that makes 8. That'll be a squared left over. B to the 11th, I could get 1 group, 2 groups, that's 8. I'd have 3 left over. And C to the 7th, I could get 1 group of 4 with 3 left over. So I'm going to go find all my groups of 4. These are all the things I can take the 4th root of. All right, the 4th root of 2 to the 4th is 2. The 4th root of a to the 4th is a, and I'm going to have 2 of those, so a squared. The 4th root of b to the 4th is b. I also have 2 of those. The 4th root of c to the 4th is c. And then what's left underneath, I have a 3, and a squared, a b cubed, and a c cubed. Okay. Now, one more thing I want to look at is when you have a fraction underneath a radical, my suggestion to you is to try to simplify that fraction first before you try to simplify the cube root. So 3 over 81, 3 does go into 81 and it goes 27 times. So 3 over 81 simplifies to 1/27. So by going ahead and simplifying that, I now have 2 numbers under here that are actually perfect cubes. So that works out a lot better. The cube root of 1 is 1 and the cube root of 27 is 3. Okay, or if we had, let's do a 5th root. We haven't done a 5th root, but it works just like everything else. All right, again, I would simplify this fraction that's underneath the radical first. 64 divided by 2 is 32. So the 5th root of 32, that does happen to be 2. All right, one more. The cube root of 16a squared b over 2a squared b to the 4th. Now, we're wanting to simplify this before we try to do the cube root. So 16 divided by 2 is 8. The a squareds will cancel because a squared over a squared is 1. The b's, we can take 1 b off the top and 1 b off the bottom, which actually means we're going to have 8 over b cubed. I didn't really leave myself room for a fraction, but this is all under the cube root, okay? So we would do the cube root of 8, that's 2, And the cube root of b cubed, that's b. So our answer there would be 2 over b.